Welcome to this lesson on variables and expressions. Today we're going to talk about how to identify numeric expressions, algebraic expressions, and how to evaluate algebraic expressions, and identifying variables. All right. So we have a couple of vocabulary terms here. We have a numerical expression. A numerical expression is a mathematical phrase with only numbers and operation symbols. Okay, so again here, keywords, it has just numbers and operation symbols. So there are no variables, there are no letters. So in this case, a numerical expression would be basically any math problem that you see where it says to solve it. So if you had like 4 plus 7, that is an expression. If you had 9 times 2, 10 divided by 6, or 11 minus 3. All of these are examples of expressions. Notice expressions do not have equal signs. So that's one way to indicate that it's an expression and not an equation. You also have to note that equations have answers, not just that they have an equal sign. So it's not just saying like, oh, hey, look at this. I put an equal sign on it. Now it's an equation. No, 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 no. Equations have to have a solution at the end of it. So equations would have to have this little part at the end that 11 minus 3 gives you 8. It has to have both the equal sign and the answer. But for the intent of is it an expression or an equation, no equal sign for expressions. A variable. A variable is a letter that can represent one or more numbers that can change. Key parts here, that can change. So like when you're talking about any type of formula, so if we talk about area, we say that area equals length times width. Well, the length and the width of any shape can change, so we represent those by L and W. I know that looks like a T, so I'm going to erase that and write it as a cursive L. Okay, so then these are variables. They stand in place of numbers that we can change. An algebraic expression is a mathematical expression with one or more variables. So it's the same thing as up here, but now it has one or more variables. So this one is going to have variables, numbers, and operations, or it can just have variables and operations. So if we look at saying a plus 2 or b divided by 4. Each of these is an algebraic expression because of the fact that it has the variables in it. Now we call these letters, and letters are a part of the alphabet when we talk about them normally. In math, we don't call them letters. In math, we call them variables. But to help me remember algebraic versus numerical, I know that algebraic starts with A, and so it's going to have letters from the alphabet in it. That kind of helps you out a little bit. But remember, when we're in math, you don't call them letters, they're called variables. Substitution. Substitution is when you replace any variable with a number. So if I have n equals 4, wherever I see n, I would substitute. So I take the 4 and I put it wherever I see the n. So the substitution would be turning this into 4 squared plus 4. So then this would be the substitution. So I'm just going to actually highlight it here, which might not be a bad idea for you guys. That is the substitution. And then evaluate. Evaluate in math means when you substitute for each variable and use the order of operations to solve. So evaluate really is telling us to solve and make sure you're using the order of operations. So in this case, if I were to evaluate now, so I'm going to do the, so n equals 4 for n squared plus 4. So I get 4 squared plus 4. Order of operations tells me to do exponents. And then I know my answer is 20. Notice I went in top-down order and I didn't write 4 squared equals 16 plus 4 equals 20 because that implies that all of these things are equal and they're not. When you show your work, you work from the top down. So you go from one piece to the next. It's going to be really important as we get into expressions and equations further down the road. Right, so here are some key ideas, and I shouldn't even say ideas. Here's some key things for your notes, especially when it comes to this right here. So multiplication. Now that we're talking about variables, you cannot use an x for multiplication. I cannot stress this enough because here, if you use an x for multiplication, this actually becomes x times 3. X is a variable because it's a letter, and so letters are used as variables. So instead of using the x symbol, we need to get used to seeing multiplication written in these ways. You can have x and then, or you can have the number in parentheses. So even if it was x with the 3 in parentheses, or if this were 4 times 3, that means multiplication as well. This doesn't just have to be with a variable. Okay, the only one that has to have a variable and a number is this one. If you have 3x, so if you have 3 and you attach it to a variable, that means multiplication. But if you do this, that means 34. It doesn't mean 3 times 4. So make sure if you have numbers, you have to use the parentheses, or you can use a dot, or you can use an asterisk. Oof. Those tend to get a little messy. So let's try that one again. X. And then I make an X and put another line through it. Times 3. Okay, and then for division, we need to get used to seeing division in different ways. So if you look at a division symbol, it actually looks like a fraction bar. So like if I had 1/4, we talked about how to convert that. You do 1 divided by 4. A division symbol was actually created to look like a fraction because a fraction means division. But instead of numbers, we have dots on top and bottom. So if you see a number or a mathematical phrase written like this with a number on top and a variable on bottom, or vice versa, you can have the variable on top and the number on bottom. This means division. Okay, same thing here. If you were to see it sideways, this just means division. Don't let the fact that it looks like a fraction scare you. It still means division. All right, so numerical expressions and algebraic expressions. If at any point you want to pause and try this on your own and check your answers, you are absolutely able to. So numerical expressions just have numbers. So just numbers and operations. Yes, it has. I mean, really what we're looking for, expressions and equations have to have operations. In order to be a mathematical phrase, it has to have operations. There has to be something that you're going to do. So with a numerical expression, we can really focus on the fact that, yeah, there's operations, but there's only numbers. There's no letters. So we could go through here and we can find the expressions that only have numbers. So here we have 4 times 3, that's only numbers. That's a numerical expression. 75 minus 5 only has numbers and expressions. And 4 plus 6 only has numbers and operations. And I said numbers and expressions up here. Not what I meant, numbers and operations. Here, now we have variables. We have y times 3. Well, since it has a variable, which is a letter, which is part of the alphabet, so it's in the algebraic expressions, makes it algebraic. Again, we have z minus 5, making it algebraic, and x plus 6, making it algebraic. Again, it's very simple. If you see letters in it, it's algebraic. Right? Yes, we need to call them variables, but for when you're just identifying numerical versus algebraic, look for your letters, look for your variables. All right, so now we're going to evaluate each expression. And we're going to find the missing values for the table. So here we have the missing values. So what this is telling us is that we need to do W, and to go from this side of the problem. So we have these little things, I call them little function machines. Some of you might have seen them before in your math. But in order to go from one thing to the next, you have to drop it into the function machine. And to go from, to really split from this side, you have to take your number, and then here it tells us divide by 11. That's the rule. So what I'm going to do is I'm going to grab the 55, and I'm going to substitute. I'm going to replace the W with 55. So think about when you're subbing in any sport. If you go in for somebody, they have to come out. So what we do is we say, okay, I'm going to substitute 55 for W. So W comes out and 55 stays in. I can solve. I can do 55 divided by 11. I know is 5. And now that I'm done with that, I can take 55 back out and put W back in. Again, this number can change. So since W can change, we put a variable there. Okay, if we wanted it to just be 55, we would just write 55. But since we want that number to be able to change, we use a variable. So again, I'm going to substitute 66 for W. Okay, so I place the 66, I substituted in there, replace the W. 66 divided by 11 is 6. I take the 66 out, put the W back. Now I want to substitute for 77. So I replace it with 77. 77 divided by 11 is 7. And I'm done. So the 77 comes back out and W goes back in. Now we can put in more numbers for W. In this case, for the table, we were just putting in these numbers here. So when it's talking about evaluating or solving, if you see a table like this that tells you just want to use these numbers, or if you see W divided by 11, and actually we should take out this equal sign because we just want an expression. Okay. So now, if you were to see W divided by 11 for W equals 99, 88, 121, okay, that means that you take these numbers and you substitute them in for W. Okay. So you might see it in a multitude of ways. Again, here, evaluate the expression, which is down here, for n equals 1, 2, and 3. So you need to evaluate this expression for n equaling 1. So you'll have one solution for 1, and for n equaling 2, and then for n equaling 3. So I would label it here in my notes, n equals 1, n equals 2, and n equals 3. Okay, and make sure to follow your order of operations. As always, if you have any questions, be sure to write them down or email me so we can go over them in class.